This is presentation 2 on probability sampling. Probability sampling is based on random selection, meaning that each case has an equal chance of being selected. So why use probability? We use probability sampling when we need a representative sample. With a representative sample, you can make generalizations. So generalizability means that a study's result will tell us something about the population being sampled. So a representative sample resembles the population enough that whatever we find in our sample, we can say that this is true for the population as well. Let's look at an example. A study asked a representative sample of the US population whether they preferred milk or dark chocolate. 67% preferred milk chocolate. Since this is a representative sample, we can infer that 60% of Americans in general prefer milk chocolate over dark chocolate. So it's very important to ensure that your sample is representative of the population. If you wanted to say something about Bloomfield College students, so that's your population, could you use our class, this methods class, as a sample? So while it's convenient, it's not representative. Our class, first of all, is too small, but there's also likely to be bias in the types of students who choose online courses, such as students who are more likely to be working full-time. So it's not representative of Bloomfield College students. So we would not be able to make generalizations about Bloomfield College students using just our class. We would need to find a representative sample of students. Let's look at the steps involved. Similar to designing quantitative research, the steps in probability sampling are very important and need to be clearly defined before starting data collection. The first two steps are defining the population and constructing a sampling frame. Let's look at this. So the first two steps are to define your target population and to create your sampling frame. So from the previous presentation, you'll remember that your target population is a population that you want to make generalizations about. For example, students in method classes in New Jersey colleges. How do you choose your sample from the target population? So in order to choose your sample, you have to construct a sampling frame. A sampling frame is a list of every single member in your population. So for our example study, the sampling frame would be a list of every single New Jersey college student currently in a methods class. So it's very important to ensure that your sampling frame corresponds with your population. In these figures, the one to the left, we see that the sampling frame, or the list of members, has a perfect correspondence with the target population. Thus, our sample will be representative of the population. In the figure to the right, we see that there is an imperfect correspondence between the target population and the sampling frame. So our sample would not be representative of our population. Think back of that example of online students. If we only had a list of online methods students, that would not be representative of methods students in general, both online and face-to-face. So we've defined our population and have constructed a sampling frame, the first two steps. Next, we have to choose our sampling design. You have 4 types of probability sampling designs. As noted earlier, which one you choose depends on what you have access to. If you have access to a sampling frame, then simple random sampling and systematic random sampling would work. Simple random sampling, as the name implies, is a simple random sample. There are a number of online services that will generate random numbers for you, and then you return to your sampling frame or your list, and you choose those numbers for your sample. So the other way to choose a sample is systematic random sampling. You have your list and you choose every nth item to include in your sample, meaning a selection interval. So every third person or every fifth class and so on. So how do you arrive at your selection interval for this type of sampling? You divide your population number by the desired sample number. For instance, if there are 100 fraternity members in your sampling frame and you want a sample of 25, you divide the two and you arrive at 4. Then you would go down your list and choose every fourth member. Let's look at this. So here's our sampling frame, a list of every member of our population, in this case fraternity members. And we randomly choose a number to start with, number 3, because you don't want to start with 1 every time, it would not be random. And then we choose every fourth member, since that's our interval that we arrived at. So what if you have access to a sampling frame, but the population has small subsets of members or elements? In this case, you would choose stratified random sampling. For example, a study on the use of public space on campus. You're going to sample days to observe the campus, but a week has 5 weekdays and 2 weekends, and how the campus is used on weekdays is likely very different from weekends. What if you're going to study religion and aging, so for among those who are 65 and older? Because of the natural process of aging and death, you will have a smaller population of people who are age 85 and older. Stratified random sampling allows you to work around these peculiarities. So stratified random sampling divides a population into relevant subgroups, and you choose your sample from those subgroups. In the study on public space on campus, you would divide your population into 2 subgroups, weekdays and weekends, and sample from those 2 groups. In the study on religion and aging, you could divide your population into 3 age groups and then sample from those 3 subgroups. Here's an illustration for another example, say a national poll. So first you would choose your primary area, circle 1. The US is nicely clustered in states already. In this figure it shows Tennessee, but let's say it's New Jersey. Then you choose your sample location, circle 2. And here we conduct a random sample within New Jersey to choose a township. So let's say our sample location is Bloomfield. Next, we divide the town into neighborhood chunks, circle 3, and we arrive at the neighborhood surrounding our college. So within that neighborhood, we choose a random selection of a segment, circle 4. such as a town block. Let's say it's Fremont Street. Lastly, with this block, we randomly select a house on that block. Let's say that we chose Social Science Division House, which is on Fremont Street. So while there's a number of steps involved in cluster sampling, it's one of the most common sampling designs because lists of populations are not easily found. So think to yourself, do you have a list of the population that you're studying in your research topic? If not, you would likely have to choose a cluster sampling design. So let's review the types of probability sampling design. We have simple random and systematic sampling, which you would choose if you have your sampling frame, but you arrive at your sample using different methods. In stratified sampling, you have a sampling frame, but there are subgroups within that list. For example, in the study on religion and aging, there are more elderly who are 85 and younger than there are elderly who are 85 and older. In cluster sampling, you do not have a sampling frame or it would be too difficult to compile. So for example, a list of all college students in New Jersey. So it's important to recognize what resources you have in order to choose your sampling design. The most important one is your sampling frame. So what are some of the pros or the benefits of probability sampling? The most important one is that it's generalizable. This means that you can say with confidence that what you found among your sample is the same as the population. However, there are some cons. First, it's very time and resource consuming. And also, sometimes the population you're looking for is hidden or it's impossible to find a sampling frame. For example, persons with a specific illness or undocumented immigrants. Neither of these populations would have a readily available sampling frame to use. So what do? You would use non-probability sampling. That's the end of presentation 2.